for exam 2 for circuits. All right, so first topic we've covered since the last exam. This is exam 2. First topic was the delta Y connections, and I'm going to just cross that out directly for you because it's not going to be on this exam. All right, mesh analysis is the next topic. Remember, the steps for this are to label or assign. Step 2 is to apply KVL. And step 3 is to solve. All right, so assign, apply, solve. And don't forget, as a subtopic here, that we have to remember what to do with a super loop. All right, superposition. All right, what superposition tells us is that the voltage or current through an element is equal to the sum of the stuff from each individual. So basically, the sum of V for each independent source is equal to V total. All right, what are the steps to apply this? First one, turn off all independent sources but one. All right, so we'll leave one on. Find the desired values. Next, we'll repeat step 1 for all independent sources. And then 3, sum the total contributions. All right, so altogether, we will be getting the total contribution from all independent sources in the circuit. Keep in mind that if we have a dependent source, we have to do something a little different, but that is a detail left up to the problems we've done and examples we've done in class. All right, source transforms tell us that if I have a voltage source with a series resistor, we'll say this is R and this is Vs, then we can transform this to a current source with value Is with a parallel resistor, and R is the same between the two versions. Vs is equal to Is times R, and Is is equal to Vs over R. All right, Thevenin and Norton. Remember that Thevenin tells us that if I have a circuit with two terminals, it can be represented as a voltage source with a series resistor. All right, V Thevenin and R Thevenin. And V Thevenin is equal to VOC. All right, assuming there's nothing connected across those terminals. And R Thevenin is equal to REQ with independent sources off. All right, all the independent sources off. All right, on the other hand, Norton tells us that if we have a very similar looking circuit that can be written instead as a current source with a parallel resistor, which has values IN and RN. And IN is equal to I short circuit going through those terminals if you connect the wires. RN is the same as R Thevenin. And we can convert between the two using a source transformation. IN is also equal to V Thevenin over R Thevenin, which means that V open circuit is also equal to I Norton, R Norton. All right, it's just a source transformation. Maximum power transfer tells us that the condition for P max is that RL is equal to R Thevenin, and the maximum power you actually get is equal to V Thevenin squared divided by 4R Thevenin. All right, then op amps. Key for op amps is that there is 0 input current and there is 0 differential input voltage. All right, so if I look at this, minus plus, that means that V1 and V2 are equal, and that the current which goes in is equal to 0. All right, that's the keys for op amps. Capacitors, what we want to remember about capacitors is that I is equal to C dV dt, which means that V is equal to the integral of I times 1 over C. Okay, and these combine in a specific way. They combine where parallel add series are like parallel resistors. All right, inductors. In this, we remember V is equal to L di dt. And these combine like resistors. All right, and then the last thing is source-free RC circuits. If I give you something that looks like this, resistor, resistor, capacitor, then V of t, which is the voltage across this capacitor, is equal to V naught e to the minus t over tau, and when t is greater than or equal to 0, and tau is equal to RC. All right, source-free RC circuits. So those are the topics that are covered on the second exam. The only one that you can ignore for your studying is the delta Y.